Thank you, Anthony, for the opportunity. Good day, everyone. And obviously, just to add up on the ongoing conversation, and you can see that there's a very good outline coming along in terms of the future automation, sustainable automation. So at AI Drivers, our vision is to deliver AI-enabled autonomous mobility solutions, which provide optimization and efficiency and for sustainable future. And obviously, as a few of our key speakers has pointed out, and port operations is a great demand in the future, and where 90% of the global trade happens in there, and the continuous growth. And based on the ongoing research shows that the key challenge at the moment is optimization of operation to improve productivity and reduce operational cost, right? And this shows that obviously there are Kickring, which has a semi-automated Kickrings at the moment. And we also have a limited automation from the Yachtring side, and on some extent lack of automation on the vehicle side. Obviously there are AGVs, but still there's a huge amount of gap that requires that. But when we talk about seaport, we don't have obviously more than Kickring, Yachtring, and trucks and few other mobile platforms. And from our perspectives, obviously to emphasize on the back of the ongoing conversation that the need is a self-aware operation, and that provides resilience, efficiency, and much better predictability. That also provides that the current shipping industry demand for the quality of service with consistency. Now, today, every port operators are really working towards that, providing that predictability of the services, right? So that's what AI Drivers has been focusing. Obviously, we started from probably the most hardest part, where we look at how we can materialize on existing fleets, and that automatically focusing on retrofitting existing fleets and making autonomous automations more accessible, and how without waiting for a new vehicles, without waiting for the environment upgrade or infrastructure upgrade. So we thought that we should do the hard bit. So, and we designed a set of software solutions from basically making existing manual driven vehicles drivable by machine safely, and more importantly, with the precisions and necessary software for navigation and fleet system and digital twin that enables this undisruptive autonomous automation deployment. And we just need to make sure that current terminal operators cannot stop operating, right? And when we bring in new technology, it's very, very important that we can consider their obligations, that they cannot stop operating. And there's a need of effective approach that how we can start automating with one way of without changing in the ongoing operations and without disrupting ongoing operations. So the same way as I said, that when we are converting existing fleets, we don't take away existing experience. So all we do that we upgrade the age equipment. So if we talk about the vehicle, we upgrade that vehicle, and on the other hand, we don't take away the existing manual driving experience in that. We just provide autonomous ability and as well as remote control on these equipments. And this makes this particular autonomous mobility automations more accessible and more comfortable for port operators. And when there is no need for infrastructure. So to just show how it works, obviously it requires environment mapping, where we map out the terminals, and obviously it requires retraining the perception engine, and that provides the fully autonomous driving in existing terminals, right? So in this case, we can see how the vehicle works, and we can also provide that how existing vehicles are driving around. So the automation we provide is for existing terminals and mixed environment. It's very, very important that we have that the simplistic approach, and as well as build up the confidence that providing that how the system works, and identifying the stability of the system. So beyond that, I think one of the area that the question was talking about the predictability of the maintenance. In our case, our system run on the equipment. That means it knows exactly how the equipment dynamics are, and it provides profile the system thoroughly. So it build up the actual the behavior model of the, in this case, the engine or the braking system or any other components, and it can diagnose and as well as the prognose the deterioration on the vehicles. So in our case, that obviously the predictability is only effective if there's enough data. But in our case, we generate the data that is more appropriate for machine learning. So beyond going that, obviously building autonomous vehicles are more effective, but providing that connectivity, the V2X, you know, to enable that self-aware operations that we have our fleet system that enables to connect not just vehicle that is autonomously drive, but any other vehicles. That because from our fleet system, it doesn't matter it's autonomously driven or manual driven, and including any other equipment, including a traffic light or cranes or gate or charging station that you can connect. It provides that the communication channels that enables that self-aware operations. And moving forward, obviously the digital twin, and everybody's talking about digital twin, but in our case, our digital twin is different. So in our case, that we replicate the terminals that provides the full accessibility of the operations. This enables us to carry out our work with the safety and as well as without disturbing the existing operations. So in our case, that the same algorithm that control the real crane, it controls the virtual crane. The same algorithm that drive the real trucks, it drives the virtual trucks. So our simulations are built based on the physics models. So we can incorporate existing the noises and existing the factors that in the real world, and as well as it enables us that if operator would like to know how it will work in a certain situation, that we can do certain tests in the use cases and scenarios that's not possible in the real world. And this gives us something more appropriate that never been possible before. Basically, how we test the TUS operation and TUS optimization, environment optimization without disturbing. So we can hook in our digital twin to a TUS and provide the trucks, cranes, traffic light, all the things that real environment provides. And this also helps us to generate the data, to rescale the data, to make the machine learning more effective. Obviously, the current limitation of machine learning is data availability and the data knowledge. One of the biggest the limitation for machine learning or AI is the knowledge representation, and in this case, coming back to the data, right? So in our case, that we can rescale the data based on existing data, and that gives us much better approach for optimizing the brownfield terminals or designing new terminals. So this gives us that level of ability. So going back to the same system, obviously we are also providing the system onto the Kickring, right? Kickring is one of the most the important components for the port operators, because they're where the throughput is associated with, right? So how you localize the container on the ship, how you map the ship, you know, how you look at the position of the containers and where your anti-sway will work much better. And the same goes on the yard side, how you have the being able to locate the container with the precisions of the centimeter or millimeter levels that enables that current the cranes be able to load and unload the actual container back and forth. So obviously, in our case, that we are taking away environment changes, we are taking away the environment, the infrastructure upgrades that makes more cost effective and that makes more accessible for the solution that we are providing. And effectively, the minute that we said that there's no environment upgrade or environment changes, so that gives you that the cost reductions. So in our case, that the solution that we are providing has a very the short-term ROI and or immediate cost reduction. So we can provide the retrofitting as a sales, which they want to recover the investment within 2 years, or we can provide the mobility as a service, which they can reduce, go up to 50% of the cost and current mobility costs in this context, right? Just to give you one example, backing up this, obviously these vehicles are at the moment the vehicle that we convert is majority of the diesel. So they drive around the clock. Majority of them is drive over 50,000 kilometers. If you talk about the fuel efficiency, minimizing the waste, you know, and taking care of that engine idle time, taking care of that effective path, right? And that provides up to 30% of the fuel efficiency. that itself creates a new Amazon for lowering emissions by minimizing the waste. So I think that's from my side. Thank you very much.